In this video, I will be explaining binary and variable in the easiest way to you. First, what the hell is a binary? So we usually use decimal to count stuff. Decimal means if we add another number to 9, it will round it up to 10, which is 10. It's the same in binary, but we have to round it up if the number reaches 2. Counting in binary is like 0, 1, 10, 1, 1, 1, 0, 0. Your computer uses binary to store data. The smallest unit for computer storage of data is a bit. A bit can have two possibilities. It is either 0 or 1. 1 byte is 8 bits, and there can be 2 to the 8th power of combinations. You can convert decimal numbers to binary, but before we do that, you need to know something. That is 2 to the first power in binary is 10. And 2 to the second power is 100 in binary. You will see a pattern here, so 2 to the third power is 1000 in binary. Pretty cool, huh? Let's say you want to convert 78 to binary. 78 is 64 plus 8 plus 4 plus 2. That is 2 to the 6th power plus 2 to the third power plus 2 to the 2 power plus 2 to the first power. Remember the pattern I just said earlier? Convert into binary and it will be 10000000 plus 1000 plus 100 plus 10. That would be equal to 1001110. Here's a question for you. Convert 101100, a binary, to decimals. If your answer is 44, you are correct. 101100 equals 100000 plus 1000 plus 100. Do the same pattern thing but the opposite. It would be 2 to the 5th power plus 2 to the third power plus 2 to the second power equal 32 plus 8 plus 4 equal 44. Got it? Suddenly you remember that in decimal we have negative numbers. Do we write a minus sign in front of a number to mean that it is a negative number in binary? No, but it would be more complicated. Before explaining, we must first understand signed integers and unsigned integers. A 32-bit system has 32 bits, which means that it can store only 32 digits, and the largest number is 32 consecutive ones. According to the sum formula of the geometric sequence, we know that it is equal to 2 raised to the power of 32 minus 1. Under the other unsigned integers, this is its range. But if it was signed integers, its range must be evenly distributed between positive and negative numbers. This is to say that maximum positive number is 2 to the 31st power minus 1, and the negative number is 2 to the 31st power. You will find that the bit in the 32nd grid seems to be forgotten. This is because it is used to indicate the positive and negative of the number. If the number in this grid is 0, it means that the number is positive. If it was 1, the number is negative. The negative number is slightly different from the positive number. Negative numbers starts from negative 1, which is 32 ones, to negative 2 raised to the 31st power, which is 1 followed by 31 zeros. There are 2 steps to determine the size of a binary number. First, check the first number. 0 represents a positive number and 1 represents a negative number. Let's look at the next 31 numbers again. As long as the following numbers are larger, the number will be larger. Question time. You can see that there are 2 integer binary numbers here. Which one is larger? If you said left, you are correct. Question 2. If you say left, you are correct. Finally, we have to enter variables. In human terms, variables are to request a warehouse to store data from the computer. Before using variables, we have to write a program to tell the computer the request, which is called declaration. The formula is variable type, variable name equals stored data. You're basically telling the computer, hey, I want this type of storage, and its name is, it's gonna store something. The variable types will be discussed later. Let's talk about the variable naming rules first. First, name it with English, which is A to Z, numbers or underline. Second, you cannot start with a number. Third, you you cannot use keywords as names, such as naming variables as int. Don't be a jerk. If the computer can understand it, then you'll be able to do anything. Finally, case sensitive. APPLE, APPLE, APPLE are three different names. Well, coming to variable types, let's look at the integer first. This type is usually used to represent integers without a decimal point. First, int. The occupied space is 4 bytes. This is a 32-bit system which represents a range from -2 to the 31st power to the 2 to the 31st power minus 1. Second, unsigned int. It is also 4 bytes and uses an unsigned integer, which means it cannot store negative numbers. Its range is 0 to 2 raised to the power of 32 minus 1. Third, long. As the list suggests, it is very long and larger than int, using a full 64-bit signed integer ranging from -2 to the 63rd power 2 to the 63rd power minus 1. Fourth, unsigned long. It is the Pro Max version of unsigned int and its range is 0 to 2 raised to the power of 64 minus 1. Floating point numbers are used to record decimal points. Because the binary system causes slight errors in calculations, they can be ignored in most cases though. First, float. Occupy 4 bytes, accurate to approximately the 7th decimal place. Second, double. Float Pro Max version. Occupy 8 bytes, accurate to approximately the 15th digit after decimal point. Characters. Characters are used to store characters. Literally, they are translated according to the ASCII code in the computer. Simply put, you can type a bunch of text or symbols in it. As long as the ASCII code is recorded, it will be converted into a binary storage and it will be translated from the system when necessary. First, CHAR, used to store one character and the size is 1 byte. Second, string. Used in most cases, it can store many characters and the size will change according to the characters stored. Boolean value only stores one true or false, with bool as the type. The theoretical size only needs 1 bit, but in most cases, it will change according to the translator. More often, it should be 1 byte, which is more convenient to read. The smallest unit of reading is byte. Alright, today we covered the basic of binary and how variable works in C++. Hopefully, this helped you understand the programming fundamentals a little better. If you found this useful, that means I'm understanding it the right way too. Still learning, you know?